மாட்டீங்களா? ஓகேவா? So now we go for transistor. Transistor, okay. So the transistor are two types. One is NPN, another is PNP. NPN, another one is PNP. The central block is called base. Central block is the base. Central block is the base, and other two blocks are emitter and collector. So in fact, transistor can be used as an amplifier and oscillator. Amplifier. It can be used as an amplifier. Can be used as a switch. Okay. So emitter, this one is emitter, this is collector, this is a base. So this one is for NPN and this one is for PNP. Emitter, collector, base, emitter, collector, base, emitter, collector, base. Okay. Emitter E. Emitter is denoted by E. Supplies a large number of majority carrier. Supplies large number of majority carrier. Supplies large number of majority carrier. Majority carrier. Supplies large number of majority carrier. Okay. For the current to flow through the transistor. 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 Okay. Through the transistor. For the current to flow through the transistor. Base B forms the central segment. Base B forms the central segment. Central segment. Base B forms the central segment. Collector is a segment that collects the carrier. Collector is a segment that collects the carrier. Collector is the one that collects the majority of the carrier. Okay. Emitter, what is emitter now? Emitter. Transistor. So now the emitter which emits the majority of the carrier, base is a segment, and collector is the which one collects the majority of the carrier. Okay. So, I am taking two junction which is PNP, here it is NPN, that is two types of transistor we having. So, I am attaching the potential difference is VBE and potential is here is CB, okay, CB, EB, here potential difference is CB, BE, BE, BC, CB, CB. So, the potential is CB, current is current is CB. So, the current this is current region which is CB, potential is CB. So, current voltage is EB, here potential difference is EB. So, current total is CB. So, this here also potential is potential also the potential is CB, CB. Potential is EB, here also EB, current is the current passed, and the main here is EBC, EBC, okay. Here PNP, NPN, which will have P will have what? Excess? P will have what? Excess hole. Excess hole is denoted like this. N will have excess electron, excess electron. So, this is the thing. So, if I attach like this, so what will be the output? That we will see. Take this picture. Sir, here emitter is equal to collector plus base. Here it is collector is equal to emitter plus base. Okay. Next, common emitter transistor. Common emitter transistor. Common emitters transistor. The input is between base and emitter. The input is between base and emitter, and output is between collector and emitter. The input is between base and emitter, and output is as a output is in the collector and emitter. The input is between base and emitter, and output is between collector and emitter. The variation of base current with base voltage, variation of base current with base emitter voltage the variation of base current the variation of base current with base emitter voltage is the input character. Similarly, the variation of collector current, similarly variation of collector current with collector emitting voltage, with collector emitting voltage is the output character. Is the collector emitting voltage is the output character. Is the output character. Is the output character. So the input is given as input resistance is defined as input resistance is defined as resistance is defined as rate of change of voltage to the rate of change of current. Rate of change of voltage to the rate of change of current. Output resistance is defined as 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 rate of change in the rate of change of voltage to the current. Output voltage is defined as rate of change of current, rate of change of voltage to the current.
Rate of change of current to the voltage, or rate of change of voltage to the current?
Voltage to the current.
Voltage to the current is inputless, sir?
No, right. The just rate of input voltage to output. Output also rate of change of current with rate of change of voltage with respect to current. So the rate of change of resistance input is equal to rate of change of voltage with respect to current. BE, what is BE? Base base emitter. So rate of change of current with respect to base. This one is with constant, this one is constant, collector base. Now rate of output is equal to rate of change of voltage, collector, emitters. This one is base emitter, this one is collector and emitter with rate of change of current in the collector at constant base, constant current base. This one is constant. This one is constant. Did you understand this? Okay, both are rate of change of voltage. This also rate of change of voltage with current. This also rate of change of voltage with current. This is constant voltage at constant current. Okay, only thing BE, IB, CE by C, IB. Okay, then current amplification factor is given by delta IC divided by delta IB. So this is rate of change of current with respect to rate of change of current. This one is IC, IC is collector, this one is base with CE which is constant voltage. Okay? Now transistor. Transistor as a device. Transistor as a device. So a transistor device, it has two application. It has two application. Two application means how will you write? No. Two application means how will you write? It has two application. As transistor, as switch, as a amplifier. As a switch, as a amplifier. As a switch, as a amplifier. As a switch, as a amplifier. So if it is used in the cutoff region, in the switch, it can be used as a switch. If it is used in the cutoff region, it can be used as a switch. If it is used in the cutoff region, it can be used as a switch. If it is used in the active region, it can be used as a transistor amplifier. It can be used as a if it is used in the if it is used in the active region, it can be used as an amplifier. Okay, so now it can be transistor can be used as a switch as well as amplifier. V0 is switch in switch V0 is equal to VCC minus IC RC. What is CC?
Common collector.
IC is current collector. RC is RC is resistance collector. AV is equal to minus beta AC RC by RB. What is RC? Resistance collector, resistance base. Beta is delta IC by delta IB. So current collector, base current. Okay?
Yes, sir.
Huh?
Oh, sir.
Over? Okay. Feedback amplifier. Okay? Feedback amplifier. So in an feedback amplifier. No, you draw this later. Let it be this. First I will tell the one thing, then you will take. Okay. In an oscillator, in an oscillator, in an oscillator, in an oscillator we get the AC output. In an oscillator we will get we get AC output without any external input.
AC?
In an oscillator we get AC output without any external input. AC output without any external input. Without any external input, in an oscillator we get an AC output without any external input. In other words, output in an oscillation is self-sustained. In other words, output in an oscillator is self-sustained. In other words, output in an oscillator is self-sustained. What is self-sustained? Self-sustained. Huh? Yeah, own. Self-supported. Self-supported means own. So, to attain this, amplifier is taken. To attain this, amplifier is taken. To attain this, amplifier is taken.
Amplifier?
Is taken. So, a portion of the output power, a portion of output power is returned back to the input. A portion of output power is returned back to the input in phase. In phase with starting power. In phase with the starting power. With starting power. In phase with the starting power. Hence, this is called positive feedback. Okay. So, input. This is the input. Okay. Transistor amplifying. Output. Okay. What do you mean by this? Can you tell me? Can you tell me what you understood from the sentence? From this diagram and this forms and this. See what I told in the sentence is clearly in the diagram. So that means what? Just it's given in the diagram. If you tell this, that means you thoroughly understood. Simple, only one word, that's all. Simple. Already given in the sentence, plus it's given clearly in the diagram. Clearly in the diagram. Self-sustained is a output, second point. Self-sustained is the second point. What is the main point? If you tell that main point, second point is self-sustained, or in other words, it is a second self-sustained. Simple, output is connected to the input. Output I am getting, input you have to supply the power, okay? Instead of power, you are supplying, not instead of power, in addition to the power, you are supplying part of output to the input. That's all. Part of to the input. Input you are supplying the power. Input means you have to supply power, okay? If you are supplying the output to the input, so input plus part of output. Input plus, this is the input, okay? This is the input here. Input plus part of the output. Output means not entire output is connected to the input, okay? Part of the output. That means it could be 10% or it could be 20%. 10% or 20% of output is connected to the input. 10%, 20% of the power is connected to the input. That's why given, what is the definition there? What is the definition? What is the definition I told you?
A portion of an output power is returned back to the input in phase.
In phase. In phase means what? Starting power. Starting input you are supplying some power. That that phase and this phase are combined to get the that both are in phase. That's in phase. That means both are combined. Not the entire output is connected to the input. Part of output plus input are connected. Both should be in phase. Both should be in phase means what? Both should be in phase means what? For example, this is the input I. This is the part of output. Okay? Part of output, this is the input. Both should be the in phase. That is where this phase is located, this should be located, and where it is output, where it is located. Like this, that is both should be in phase. Both should in phase means one, this is the input and this is the part of output. So only part of output means what?
Only 20%.
Something like 10% or 20% are from the output. If I connected at 10%, what will be remaining in the output? 90%. So you forget about 90%. It went for output. So I am taking 10%, and again this input is now input now. What will be the, how much will be the input now?
10%. 90% is
See, output is there. Part of output I am taking it. So which is 10%. Part, not fully. Part means few percentage. 10% you can take. Okay, I am assuming that I am taking 10%. Then what will be the remaining output?
90%.
90% is going out. So we forget about the output now. So 90% which is going out we forget about. Only that input, only that part of output you take, which is 10%. Now I am connecting to the input. What will be the percentage of the input now?
10% plus the
Huh?
10% plus
Plus?
input. Part of output.
Input plus part of output. Our part of output is 10%. What is the input now? 90%. That is the thing here. So 90 plus 10%. 10% is part of output. Okay? This one is full input or just input. That's all. Okay? So this should be both are in phase. This 90% and 10% both are in phase. This was the input, which is 90%. This one is part of output, which is 10%. So both should be the in phase. Both should travel in the same phase. So you take this diagram, and frequency is equal to 1 by 2 pi root LC. Resonance frequency. Resonance frequency is given by 1 by 2 pi LC. L is inductance. C is the capacitance. Okay, you taken this this one? This you taken?
Yes, sir.
Okay. Now, can I rub?
Yes, sir.
Now we go for digital electronics. Digital electronics. Did you ever did you ever seen did you ever seen black and white television? No, it's not available here. TV. Did you ever seen black and white television? You forget about color?
Old movies.
Old movies. I'm not asking old movies. Old movies you can see in the color television. I am asking very old television which came in 1980s, 1990s. Okay. After that, the production was stopped. Color TV was introduced. Okay. 1980s especially. 1980s especially. Full of is a black and white TV only. Okay. Okay. It will be like this. It's like screen like this. It will be this table size. Okay, it will be like this table size. Did you ever seen that in your lifetime? No, you can't, because they stopped production last year towards the 1980s, 1990s, 2000 till 2000 they manufactured it. But late 2000 color TV they came on production. So people used to buy color TV. No one used to purchase that black and white TV. It's not available now. It is not available nowhere. Nowhere it is available. Nowhere it's available. Nowhere in the world it's available. The production was stopped. The technology they closed it. The technology itself they closed it. Technology if there means they can use for production of manufacturing. But you have to produce the pattern. All the company will design an instrument, design the television, and they will universities, engineers, electrical engineers in the university, they will design that technology, and your company will purchase the technology and manufacture it. Because now digital came. Digital came. See this in this television you can see movies of 1950s, 1960s movies you can see, but you can't see old television. The engineers they designed in 1980s. So that was purchased by the company and they manufactured the television. And to late 2000, what happened? The people stopped purchasing the new television. Television came. New television came. New color television start coming late 2000, around 2000, in the year 2000, around 2000. That means 1995, 1996, 1997, 1998, 2000, 2001, 2003, 2004. So when this station is there, what happened that around 2000 new technology came. So another company, another universities, there are plenty of universities. So they designed the new technology of color television. So what the industry did, what industry did, they stopped purchasing the old technology and they went for purchasing the new color television. Example is this. So this is an example. So what happened now? The old television, black and white color TVs, which is available in the late century, late around 2000. It's not the production is stopped. The entire production was stopped late 2000, around 2000, not late 2000, around 2000. 2000 means 1995 to 2005. So by 2001, 2002 also it's available, and so it's completely stopped, and you are never seen anywhere in the world. Did you ever seen color black and white television? Do you see? But you have seen old movies, 1940s, 1930s, 1950, 1960, 1970, etc. All the old movies you can see in this television, but you've never seen. So that's different. That's technology is analog, and this technology is digital. That's the difference between analog and digital. So the analog, in the analog means the signal will be ramped. Ramped means something, not definite shape. Here digital means it is, so this one is 0, this one is 1, 0 and 1, 0 and 1. So something different, some different is came. Here it is random, so no color, nothing. Here it is fully colored, fully colored. So you get 1 and 0, 1 and 0, one thing, definite value, 1, 0. So this is a definite value, definite value. Here you can see it's a definite value, here it's a undefinite value. Undefinite value. So this is a trend of so this is a trend of late of analog digital. So this technology is overcome by this technology. Why this technology overcome? See, there is advantage. What is the advantage of this and what is the advantage of this?
We can see the color of the
It's a color pollution. Here you can't produce the color. See, something you have to produce new so that the industry will buy it. So if you are engineers, you have to design that board. If you design the board, then the industry you have to show some advantage. I'd say you have to show some advantage. What I showed is what university showed, some university. There are plenty of universities there, engineers, the universities, they developed the one board, they are saying that this is the digital, it's a definite value, it can show the colors now. So company what they did, they stopped manufacturing that black and white production, which is analog, undefinite value. They start manufacturing this definite value, which is digital. So everybody shifted to digital. Now the production is completely stopped of analog, the black and white television. It will be like this. It will be like this board size. It's a very big television with screen, everything. You have not even see. You can read in the. You can see in the Google. You can see in the museum. You can see it. They might have kept in the museum. Yeah, it's completely stopped. It's almost long back. 20 years itself they stopped it. Nobody has, not even single thing they. You can't find it because it's 20 years back. Probably 20 years back we might have seen it, but now nobody has seen it. So they kept in the museum something like that, or something like that, some rare place they might have kept and using it. So this is so technology innovation. Technology means you have to show new advantage, new things. If you say new thing, if you say new technology introduced, then the old technology will vanish. So so people engineers introduced this board and said to the company, yeah, we have introduced this. This is the which is a digital value, a digital one. It has many advantages to this thing because it has a definite value as well as you can produce the colors. But here no colors is produced. So the company purchased the patent. Everything is money, not free of cost. Now nobody will give free. Everything is money. See, if this one is they purchase it will be almost 10 times. Money is 10 times. So the company has to purchase this with the 10 times this value, this patent. So 10 times if they 10 times they will purchase 10 times and manufacture the things and they will sell the television another 10 times. So the business, it's a business. So both who is profited here? Huh? No, everybody is profited. Not only engineers, company also. See, engineers got 10 times money, the patent. The patent they sold it 10 times. So they got the money. Now company what they did, they purchased the patent and sold the television worth 10 times. This and this is very different. This television, what it costs, the color television will cost 10 times of it. So they got huge amount of money. Now, what they purchased the patent, they sold it for 10 times. So everybody is, everywhere money. Money plays the dominant role. So that's a pattern is due to technological innovation. This technology they are introducing for money. So everything is money, everything new technology. So now everybody, this analog signal completely vanished. Nowhere available. Everywhere digital. Digital which is definite value. Okay. So now takes the thing. So did you understand this concept? Okay. The signal, current and voltage, the signal like current or voltage current and voltage will run in the continuous form, will run in the, or you take this picture like this, more appropriate. The current or voltage, the signal like current or voltage with the time varying t, with the variation of 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 t is called analog, is called analog. Okay. So, in the similar way, current that varies with time t, current that varies with time t in a definite value like 0 or 1. The current that varies with time t, current that varies with time t, current that varies with time t, current that varies with time, current that varies with time t with a definite value either with 0 or with analog. No, either with 0 or with 1, 0 or 1, that's all. 0 means what? The current is 0. 1 means what? Current is 0 means what? Current is 0. 1 means more high, high. That's all. It could be anything. It could be 1,000. It could be 10,000. It could be 1 lakh. But the overall is 1. And 0 means 0. That's all. No current. Current is 0 means no current. 1 means high current. 0 means no current. 1 means high current. Okay, based on only it is divided into not, no, otherwise wait. A gate is a gate in a digital circuit. A gate in a digital circuit. A gate in a digital circuit. A gate in a digital circuit follows logic relationship between a gate in the digital circuit follows logic relationship between input and output voltage. A gate in the digital circuit follows logic relationship between input and output voltage. Is called logic gates. Is called logic gates. Okay. So what is that? See, I will repeat. A gate in the digital circuit. A gate in the digital circuit follows relation between the input and output voltage. These are generally called as logic gates, and it is divided into 5 parts. Not. It is divided into 5 parts. Not. It is divided into 5 parts. Okay, not and or, NAND NOR. So not and is constitute the NAND, not and or constitute the NOR. First one is not. Not is one input and one output. Okay. Second one is two inputs with one output. And first one is not. Another one is no or. For or it is two input with one output. Or okay. And is two output, two different input. For and is two different input with one output. First was one is not is one input, one output. Second is two different or is two different input and one output. No, two input with one output. Okay. For and is two different input with one output. So now what is NAND? NAND now not plus and. So one output. This what is not here? One output. What one output, one bit. NAND is and is two different output. So NAND and NAND is constituted what? NAND. Now NAND will constitute what? You understood my question? Two different input. Okay. Two different input with one output. Huh?
Two input, one output. Two input, two output. Two output, one input. NAND.
Yeah. Two output, one input. Reverse. What is and two input, two different input with one output. But here NAND is two output, one input. Two different output, one input. NOR is one input, two output. NOR you understood? NOR. What is NOR gen? Two output with one input. NAND is two different output with one input. You understood now?
Yes, sir.
What is NAND?
Two different input with
Two different output with one input. NOR is two output with one input. That means NOR two output is no. Our two output will be. You understand NOR?
Yes, sir. Opposite input output.
Okay, that's okay. NOR you got two output with one input. In here two output should be same. NOR same. NAND தான் different. NOR not different. Now you tell me what is not.
One input and two different output.
See, you confused everything.
Sir, not one input, one output.
One input, one output. Is it okay for you? One input, one output for not. Okay? NAND and
Two different input,
two different output, two different input with one output. Then OR
two input with one output.
Two input with one output. So the two input are
Same.
input same. Now you go for reverse. NAND.
And one input, two different
Output. One input, two. No, you let her tell. What is still for NAND and NOR? NAND and NOR.
NAND, one input, two different output.
NOR?
One input.
No, she has to tell. One input.
One input, two output.
Two output. What is the two output?
Same.
What is the two output? That's what you have asked.
Not plus same. Same or different?
That's what you asked. Same. So this should be same. It should be same. Now you understood? Now you tell me everything for not and or not or. You tell me.
For not one input,
One output.
or two input, one output. And two different input, one output.
Wait. And for and.
Two different input,
Put.
one output. NAND, one input.
What an R? You go see here. First not and or. First you tell for NAT. Not. Not.
One input, one
And.
two different input, one output. Two input, one output.
Two.
Input, one input.
Or. No, and.
Two different input. Notக்கு one input, one output. Andக்கு two different input, one output. Orக்கு two input, one output.
So two input is.
Two input is same.
Two input is same. Yeah. So now you understood?
Sir.
Now go for NAND.
NAND, one input, two different output. NOR வந்து one input, one same output.
Two output, same output. Okay? So many logic gate now integrated chip, integrated circuit IC, integrated IC, integrated chip. No, integrated circuit, which is IC, integrated circuit which is IC. So many logic gates are integrated in one chip. Many logic gates are integrated in one chip. It is called integrated circuit. Many logic gates are integrated in one chip. Many logic gates are integrated in one chip. Many logic gates are integrated in one chip. It's called integrated circuit. Many logic gates are integrated in one chip. Many logic gates are integrated in one chip. Many logic gates are integrated in one chip is called integrated circuits, IC, which is called IC. The output is, first point did you understand? Many logic gates are integrated into one chip. It is called integrated circuit. Okay. Then output is more or less equal to input. Output is more or less directly proportional to the input. More or less directly proportional to the input. The output is more or less directly proportional to the input. Output is more or less directly proportional to the input. More or less directly proportional to the input. That means output and input are almost same. So it linearly varies with input, and it linearly varies with input. Linearly varies with the input. And it is three types. It is three types. Three types means how will you write? Small, medium, large. It is three types. Small, medium, large. Small means it will have 10 logic gates. Small means it will have 10 logic gates. Medium means it will have 100 logic gates. Large means it will have 1000 logic gates. It is commonly found in motherboard. It is commonly found in all motherboards. Especially in television and laptops, computers. No, IC. No, small, medium, large. Small will have a 10 IC. Small means 10. Medium means 100. Large means 1000. Okay. So it is commonly used in all motherboards like television, laptop, and PC. Okay? Okay?
Yes, sir.
That's all. We have finished plus 2 syllabus. Okay?
Yes, sir.
Okay? So any doubt is there in till now what we taken? Any doubt something like that? Nothing. Okay.